Imagine you're told to run 100 meters as fast as you can, and just before you cross the finish line, it changes to 400 meters. Would you be able to maintain the same speed over the remaining 300 meters? Of course not, but why can't you? Because your muscles refused since they were told it would only be 100 meters. Not really, and the fact is your muscles aren't to blame. Muscle contraction requires energy from a molecule called ATP, not the Association of Tennis Professionals. But it is something tennis players love, they just don't know it. This ATP is adenosine triphosphate, a molecule that contains energy in its phosphate bonds, and is the only source of energy your muscles can use. But since your muscle fibers don't store a lot of ATP, they have to rely on the metabolic energy systems to transfer energy from other fuels into new ATP. It's the inability of those systems to provide the muscles with enough ATP quickly that's to blame for the slower pace over those last 300 meters. Intense exercise requires a fast rate of creating new ATP, which happens with anaerobic energy production and its two systems, anaerobic glycolysis and the ATP-PC system, each with their own advantages and disadvantages. This video covers the fastest of those two energy systems, the ATP-PC system, which is found in all muscle fibers, but more so in fast-twitch fibers, and is the primary energy source for the muscles during a 100-meter sprint. Here's how it works. Phosphocreatine, another high-energy molecule found inside the muscle fibers, but with energy that the contractile proteins can't use, is acted upon by an enzyme called creatine kinase. This separates phosphocreatine into phosphate and creatine, while at the same time its energy is released and immediately used in another reaction that combines ADP and phosphate to form new ATP, an energy source the contractile proteins can use. And that's it. Being so short and simple means it's faster at making ATP than glycolysis or the aerobic energy system. However, it can only provide a significant amount of energy for a few seconds because so little of it is stored inside the muscle fibers. But its speed does make it the primary provider of ATP during all-out events that only last a few seconds, like heavy weightlifting, high jumping, throwing a shot put, serving a tennis ball, or trying to outrun a saber-toothed tiger. Just seeing if you're listening. While the ATP-PC system provides the majority of energy in these cases, ATP is also produced but to a lesser extent in glycolysis and the aerobic system. For example, if your 100-meter run now requires an additional 300 meters, the ATP-PC system doesn't shut down, but it keeps providing energy in the background, just not as much. And at that point, glycolysis takes over as the primary energy producer. But since it's slower at doing so, your sprinting speed will also become slower. You see this with the women's world record for 100 meters, which is 10.49 seconds. But the women's world record for the 400 meters is not 4 times that, or about 43.3 seconds. Instead, it's 47.6 seconds, about 4 seconds or 9% slower. If you perform any high-intensity activity repeatedly, like jumping for a rebound 3 to 4 times that nobody can control, you'll notice your jump height gradually decreases as the phosphocreatine inside your muscles depletes. This means not enough ATP is made fast enough during the third and fourth attempt, which allows Charles Barkley to come over your back and get the rebound without being called for the foul. Typical. However, if you give your muscles a few minutes to recover between each attempt, the aerobic system will provide the energy needed to reunite phosphate and creatine back into usable phosphocreatine. Once the phosphocreatine is restored inside the muscle fibers, your performance should be similar to previous attempts. Now, with anaerobic training and conditioning, the ATP-PC system becomes a little bit faster, as creatine kinase and other enzyme activity increases. This means the system can make ATP faster and more of it, which will improve your anaerobic performance. You can also bolster the ATP-PC system by taking a creatine supplement, which builds up phosphocreatine inside the muscle. Research shows taking creatine increases muscle strength, sprinting speed, and helps with surges in events like cross-country skiing and cycling. Despite being the shortest, lesser used energy-producing system inside the muscles, a well-developed ATP-PC system can be a difference maker when it comes to out-sprinting that saber-toothed tiger or drop-kicking Charles Barkley. I hope this video gave you a better understanding of how the ATP-PC system works and how it applies to you. Thanks for watching. As always, my answers come from peer-reviewed research.